Hello everyone, my name's Wayne Blacklock. Thanks for sticking through it. I'm going to reward your endurance with flow diagrams, curl and bad programmer art, so I think it'll be absolutely worth your time. A little bit about me very quickly. Senior customer engineer at ForgeRock, been identity for well, I guess a decade now, 8 years prior in consulting at Deloitte. Most recently, I've been a member of the UK OpenBanking work group, along with Pam, and I'll be honest, I think it's probably one of the most exciting things I've done in my career, and I think Pam feels similarly, yes, given your excitement about these sessions. Also a joint winner of the first UK OpenBanking hackathon back in April, which I'll talk a little bit about, just to add some colour around this whole OpenBanking journey. Okay then, so open banking, what's it all about? So in the UK, the Competition and Markets Authority, that's the CMA, that's a government organisation, have mandated the 9 largest UK banks have to open up their APIs early 2018, specifically January. So this is, sorry? That's pretty early. Yeah, they're struggling with that timeline, shall we say. Specifically payment APIs and data sharing APIs. Alongside that, actually earlier, the EU Commission, with Payment Services Directive 2, PSD2, have said much the same thing. Regulation to enforce the banks to open up their APIs. And in both cases, it's about encouraging competition, making it easier for challengers to enter the market, enabling new ways of doing business, all that good stuff. So why, you might ask yourself. So yeah, it's really about the consumer. It's about giving the consumer choice. So with open banking, you can swap banks seamlessly and take all your data with you, in a matter of hours. You can pay directly using your bank account instead of credit. So this is more for the banks really, but rather than use a Visa or a MasterCard or what have you, you can choose to pay with your bank account. And then you've got things like aggregator sites, which are already happening, as Alan talked about yesterday, if anyone heard his little speech on screen scraping. You can do that now, yes, but it's not at all secure, and it's not a good answer. But that's really just the basics. And I've been involved in open banking for probably about a year now, and my eyes have been opened. It took a little while, but there's an awful lot of opportunity here, and I think I've finally come to realise just how world-changing this really could be if we get it right. So things like your bank account becomes your loyalty card, so no more carrying 20 loyalty cards for Starbucks, Pierre Chang's, whoever you happen to be loyal to. Instead, that data exists in your bank account. You consent to them getting access to that data, and then they can use that data to offer you discounts based on your loyalty, because they can see what you've transacted with them. Intelligent payment services. So I'm guessing most people in this room probably collect points of some description, probably have credit cards, something similar. So a service where you want to buy something, but you don't want to have to think about how you maximize your points. So you consent to an intermediary service which will use the card that will maximize the points for you to get most benefit. And then the third one's an interesting one. So as I say, I went along to the first Starling Bank UK hackathon. So Starling Bank they're what I call the extreme end of open banking. They've basically built a bank that is entirely OAuth API driven. So with a token and the right scopes, you can go in and do any function at the bank, transfer money, add payees, all of it. You could build a bank on top of their bank if you really wanted to. And they had a hackathon to see what people would do with that API. And I ended up meeting a chap called Rodney Hoinkes, I'm going to give him a shout out, who runs a startup called Mabel Care, which is about financial care, which is something I hadn't come across before, but it's effectively the idea of using that data from banking accounts to monitor and keep an eye on dependents. So as a carer, you might get an application which monitors your elderly mother's account, for example, and suddenly spending patterns change. They're not spending money in the same places they were and at the same times they were weekly. Well, something might be up. Either they might be depressed, they might be ill, some fraud might be going on, something like that. And we actually worked together and integrated that with a workflow engine and ended up winning the hackathon. So there's all the really interesting stuff and more stuff that hasn't even been thought of yet, I'm sure. Okay, so it's two main API flows. I've taken these from PSD2, so it's worth. There's a lot of overlap between PSD2 and OpenBanking. Prevailing view is that PSD2 can be achieved with OpenBanking APIs, at least most of it anyway. And there's kind of two key flows: payment initiation, so making payments, and sharing account data. And then also you've got a two-step transaction approach because it's not enough to handle single payments. You need to be able to handle future or repeating payments. And there's a legal requirement that payment only occurs when goods are received. So you need a setup and a commit transaction. Generally, this is the two-phase commit approach is generally the best approach according to Stack Overflow and various experts in the room. So today I'm mostly going to be exclusively looking at the commit. So this is the part where you need to consent to that payment happening or consent to that data being shared. How are we going to do that? So security pattern. We need a security pattern to do this. Turns out we've already got one. We can do it with OAuth. And a moment on anti-patterns. Again, just on screen scraping. Anyone who was in the room with Alan yesterday, screen scraping is the very definition of a security anti-pattern as far as I'm concerned. And we shouldn't be supporting it. And it definitely shouldn't be part of OpenBanking.
Wayne, if there's anyone in this room who hasn't gone to the Kantara website and signed that pledge,
yes.
Please do it.
Wait, say it for the cameras because it's getting recorded.
So if anyone hasn't gone to the URL up on the screen there and voiced their strong opposition to this, please do. Thank you.
Thank you. Okay, so as I said, this is going to be a pretty technical session. I'm going to go into the flows, how this actually all works, how you build requests, how you handle the responses, all that good stuff. What have I been using to do this? So mostly it's going to be curl. Postman's also perfectly good for making REST calls, as I'm sure many of you know. I've built a couple of quick prototype web apps in Node.js, and I use Atom quite extensively. I was asked to put a tools slide because apparently people are interested in the tools I use. I don't know. Okay, so a little bit on OAuth. I appreciate a lot of people will be familiar with it, but it's kind of the building blocks for how we get to the solution we need to for OpenBanking. So OAuth 2, widely accepted standard for API security, specifically delegated authorization. So it's a means to permit a third party to do something on your behalf. The third party receives an access token and it can use that to call APIs. APIs can then validate that token and the permissions that token has before doing whatever it is that the third party wants to do. So some terminology, for those not familiar. You have a resource owner, so the user who owns the thing being shared. So in this case, it's a customer because we're sharing bank account data. A client, the third party who wants to access that data, so an accountant. An authorization server, the thing that authorizes access to the thing being shared, and a resource server which enforces and validates the access to the thing being shared. And they're typically, not always, but often the same thing, in this case a bank. I'll spend a minute on the flows. So there's 4 different types of OAuth grants. We're going to be looking at authorization code grants because it's the most suitable for what we're doing. Reason for that is it's a 2-step. You get an authorization code, and then you exchange that code for a token via a secure channel. There are other grants, implicit grant, where you receive a token immediately, but the challenge with that is it's passed in the front channel, and it's more vulnerable. It's more that can go wrong with it. It's not as secure. Yes, it's a bit faster, a bit more performant, but for what we're doing, that's not what we want. There's also password credentials, which is a bit of a special case. You generally used by trusted mobile apps, so you're passing your credentials are passed directly to the authorization server, which is not what we want either. And client credentials grant, which is a bit special. That's more system-to-system API access. So again, not what we want. So authorization code grant it is. And here's the flow. And I'm going to go through this step by step, look at the requests and responses from each stage. It's a standard OAuth authorization code flow. So I'm going to choose to share my account data and be redirected by the client to the authorization server with a request for consent with scope to say that that the third party wants to read my account data. Then the customer is going to, well, they're not going to authenticate in this flow because I'm going to pre-authenticate and I'm going to assume consent for this part of the demo. I'm going to touch on later, look at how that actually works, but for understanding the flows, we're going to presume consent and pre-authenticate. After that, once I've consented, the authorization server is going to return back to the accountant with a authorization code, and the accountant can exchange that for a token directly. So that's not in the front channel, that's not through a browser, that's a direct secure channel with the OAuth client. And for anyone not familiar with this stuff, the biggest piece I struggled with when I started learning OAuth was the redirect. It's all of this these core flows are happening as redirects in your browser, as 302s. And that took me some time to get my head around. So if you're having trouble getting your head around it, you're not alone. Okay. So curl. So first, we need to get an authorization code. So let's do that. So I've got a live OpenAM server running locally, which I'm going to use. I'm going to cheat and use Postman very quickly just to authenticate because it's a bit quicker. I'm using our REST APIs to authenticate here. As the user demo and the password change it, the user might become important later. But the key thing for now is that I've got a token. Oh, that's not what I wanted. So what I can do is put this token into here. So this is just the pre-authentication step. We aren't into the standards-based flow yet, but that's what we're about to do. So I'll make this bigger. Which can everyone see that okay?
Yeah, except for the waves.
I can't do much about the waves, unfortunately. Okay, so we've got an authorization code request. So what's happened there? So we've been redirected from the client. So I've gone to the accountancy website. I've been chosen that I want to share my account data, and I've been redirected with 302. That's 302. Back to, sorry. We've done the authorization server. We've gone to the, start again. We've gone to the authorization server. We've got a code, and we've been redirected back to the accountancy site with the code. So that's what we're doing here. So the authentication and the consent was implied, and we've been redirected with this code. So I'm now, if I mimic the accountancy site, I have this code. I can now exchange this code for a token, which is what I'm going to do. So again, this is what I would be doing if I was the accountant. So you can see the endpoints actually. I've highlighted them to the right of where it says OAuth2. You have authorize, and you have access token. So these are standard endpoints. They're part of the spec, and everything you're seeing here is open standards and specification based. I'll call it out if it isn't. So we've got our authorization code. So what I'm going to do now is use that code and exchange it for a token, which is what I've done. And remember, I said this is a direct channel communication. This is not via the browser. But I've got this little thing called an access token here. So the third party, the client, the accountant now has an access token. And with that access token, they can present it to the authorization server, to the bank, well, to the resource server, to then get that account data. And if you see the access token has a scope as well, saying read account, that's what it's good for. That's the only thing you're allowed to do with it. Not write account, read account, because that's what I consented to. And that's what the token allows you to do. Okay, so We've also got the introspect endpoint, again, part of the spec. So this allows you to query with the authorization server as to the validity of the token, what it's good for, and whether it's still active. So let's do that quickly. So I need the access token. And okay, oh, that's not right. Okay, so yeah, token is still active. It would be because it hasn't expired. It is good for the read account scope, and it's for the user demo. So that's all the information I need as a resource server to make an informed decision about whether I allow access to this client. And that's basic OAuth stuff, right? There's nothing unusual there. And just to finish all that off, so I actually built a simple, I guess you'd call it accountant app in Node.js, which is going to, so you look here, we've got a getAccount method, which I'm now going to call, and that's going to use exactly the same introspect endpoint that I just showed you in curl to validate that that token is valid before returning the account data. So just a complete flow. So I'm using the access token as a bearer token for authorization. So this is the thing that will get presented to my API app, and I've lost my token. There it is. Okay. Okay, and the read's been authorized. So that's kind of in a nutshell OAuth. And that gets us halfway to OpenBanking, right? We can share account data, but with that model, we have no easy way to do payments. Because if you think about scopes, let me make this big again. Scopes are typically functional things. They're not granular. You can see the Google Drive scope list. So it's things like view files in your drive, view photos, read-only, modify drive scripts. There's a whole set of stuff there, but the point is they're kind of fixed things. They're not, I want to pay Amazon $500 for a television, right? Obviously, every time you do a transaction, it's going to be different. It's going to be a different amount, it's going to be a different retailer, it's going to be different information. So it doesn't fit very well with this model. But we still want to use an open standard. We still want to use a security pattern, right? We don't want to use something proprietary. That's not the right answer here. So what can we do? Well, what we can do is look at OpenID Connect. So OpenID Connect is a standard built on top of OAuth. It identity enables OAuth. So instead of just an access token, you also get an identity token. But what it also does is standardize elements of OAuth which are optional. Enables something called dynamic client registration. So that accountancy site in an OIDC world can register to be part of that ecosystem in a standards-based way. But crucially, what it does for us is it enables more granular authorization with the use of something called a request parameter, which I'm going to revisit in a moment. The terms are slightly different for OpenID Connect. So you have an end user who, again, owns a thing being shared. You have a relying party. So the party relying on someone else to authenticate that user. You're effectively delegating authentication. With OAuth, you're delegating authorization. With OpenID Connect, you're delegating authentication. An OpenID provider, which is the thing that owns the identity, that can authenticate the end user on behalf of the relying party, and again, a resource server. And again, there's some flows, and I won't spend too long on this. Again, we need the authorization code flow. The implicit flow we're not going to use for the reasons we've discussed. There's a hybrid flow which combines elements of both, but again, it's not suitable. But it's beyond the scope of this talk. And claims. So we saw with OAuth, with scopes. We can do things like read account, read drive. So OpenID Connect, we're instead working in claims. So what am I claiming about the end user when I authenticate them and pass an ID token back? There's a list of standard profile claims. You probably can't see them on the wavy thing, but things like family name, middle name, picture, website, you'll see these get returns. But again, crucially, with OpenID Connect, you can request specific claims to be returned, which is what we're going to need to do. Okay, so again, OIDC authorization code flow, basically the same, except we're going to get an ID token and an access token. And again, I'm going to step through the flow. Okay, so again, we're going to go to the authorize endpoint. We're going to ask for a authorization code with the scope OpenID and profile. So OpenID is how we know we're doing OpenID. And profile is that standard set of claims that I just showed you that you probably all couldn't read because of the screens. But anyway, so let's do that. Okay. So again, I'm going to need to be authenticated. Okay, so same thing again. We have been redirected to the, we've gone to the authorization server with a redirect back to the relying party. We've asked for the OpenID and profile scopes, and we've been given again a code. So I'm going to take that code, all of it. And again, we're going to go to access token. So this time it's going to be a little bit different. Because this time, we're going to get an access token, but we're going to get this big, long thing. And this big, long thing is an ID token. And we can have a look. It's an ID token. It's actually a JSON web token. For anyone not familiar, it's a way of structured way of storing, passing around JSON web data. And we can go to everyone's favorite site to decrypt it. But you can see what's in the ID token. So there's a signature. So you've got the signing algorithm, so you can check if it's been tampered, so you have some security assurance with it. You have those profile names and those standard set of claims I talked about earlier. So given name, name, family name. I don't have the rest populated for the sake of this demo, but you can see, so what we've got is we've asked for OpenID, and we've got an ID token, so proof of who the user is to the third party, to the relying party rather, and we've also got the claims that we asked for. So again, so far, basic OIDC stuff. And again, we've got a user info endpoint, which we can query, which I'll do quickly. And again, we're going to use the access token to do that. Okay, and there's those claims back from the user info endpoint. So that's so far standard OpenID connects, but it gets us to where we need to be, because what that means is we can now make use of the OpenID Connect request parameter, which is what this is all really about. So what is the request parameter then? So it's part of the OIDC core specification, section 6, for those interested. And what it does, it enables the relying party to request specific information about the end user returned in the claims. And crucially, you can specify the value they get returned with. So it's not just, I want their profile returned, it's I want a profile with this particular value. So what it lets you do is consent to something dynamic. We can now create requests based on transactions, so with things that are going to change, and we can consent to those things in a standards-based, secure way. So we can do payment initiation. We can do open banking. Same sort of code flow. Just this time, we're going to pass a request parameter. And again, I'm going to work through the whole thing. So first, we actually need to create a request parameter. So much like an ID token, this is a signed JOT, so I can't just hack one together. But what I can do is create one programmatically. Okay. Where did someone eat last night? Anyone want to shout out? Restaurant? Anyone? Bellwethers. Yeah, block party would have been good. We'll do Bellwethers. So basically, it's a dynamic transaction. So I'm going to create this JOT with amount $399, retailer Bellwethers, and what I'm going to get out at the end of this is when I create it. You can't really see it, but I've just run a bit of code which is thrown out a JOT. But I'll show you in JOT.io. Okay, so we've now got a OIDC request parameter, which we can use when we do the request for the authorization code, and specifically say, okay, so I want consent to the following claims, amount 399, retailer Bellwethers. So we've got a way of presenting to the user what they're actually consenting to and storing that, and again, all in a standards-based way. So let's do that. You'll have noticed the request parameter is quite big. When this is implemented, we're going to have to pay mine to the URL size limits and the like, but it's still a good answer. And what'll probably happen is you'll be passing a transaction ID and intent rather than that specific information about the transaction. It'll likely be a transaction ID because you've already set up the transaction previously in the first step of that two-phase commit, which I talked about earlier. And again, I need to be authenticated. Okay. So let's try that. Okay, so again, let's just go back to the flow to make sure we've got it clear what just happened. So I've built a retail website. I've chosen to purchase something, Bellwethers, so I guess we're at Bellwethers retail website. I have been so I've been sent the authorization server with a redirect back to the client. I've consented and authenticated, which I've done in advance. The authorization server has responded with a authorization code for that particular request parameter and redirected that back to the retailer. So again, as before, I've got an authorization code, and I need to swap that out for a token. And again, what have I done? Sorry?
Your copy doesn't include code at the end.
You just dropped the last character.
It's just a copy paste.
Okay, fine. Sorry, I'm not seeing it. I'll just do it again. Hang on, that's not right. It was. Thanks. Okay. Yeah, so again, we've exchanged our authorization code for an access token and ID token on a secure channel. And again, if we have a look at what that ID token contains, we should have the retailer, and we've got the amount. Okay. So what does that actually look like in practice then? Because that's all very well looking at flows and stuff, but what's the actual sort of user experience, and how does that translate to a real user story, if you like? So for that, we have to visit my retailer, which I built. So we're going to fulfill the role of, if I go back to the flow diagram. So this is our client retailer. So I'm going to play Dennis demo in this case. I want to buy something. I'm going to choose what to buy. Groceries, let's say. Okay. I'm going to choose a bank to pay for it. So this is the list of the CMA9 banks in the UK, if anyone's wondering. So I want to buy groceries for £33.29. I want to use my bank, so my bank's HSBC. So I'm going to select HSBC. I'm going to be directed to HSBC with a request for an authorization code and a redirect URL back to the retailer. So I'm going to do that first through, and then we can pick it apart. So I'm redirected to the bank. So pretend this is the bank who've got a secure front end. They want you to authenticate. In this case, it's just username and password, but typically it'd be two-factor or device fingerprinting or whatever you need it to be. And I'm being asked to consent. So again, imagine this is going to be skinned in a user-friendly way, but effectively I'm being asked as a user, I've authenticated, now I'm being asked to consent to a transaction for the TTP retailer for $33.29. And when I allow this, we're going to return back to the retail site with the authorization code. The retail site's going to exchange the authorization code, the ID token and access code, and then make the payment. And we've got another API here off to the right, where you should see that payment pop up. And again, I can show you what's going on there briefly. So we've got a payment route. So we're coming in with a bearer token. We're going to the user info endpoint to check that that token is valid and what it's valid for. And then we're returning a response based on whether it's authorized or not. And we're pulling out the actual data from that token to say what it's for, so the retailer and the amount. So when I hit allow, if I haven't waited too long, which I might have, okay, purchase is complete, authorized to TTP retail for $33.29, and we have a transaction which just popped up in here. So that's kind of a typical open banking flow that I would expect to see. You've probably exchanged the API you just saw for a gateway. What I'm seeing in the field is a lot of banks using dedicated API gateways and wanting to integrate with authorization service to validate those tokens. So that might be an Apogee or a whatever API gateway. Okay, so that's kind of how open banking is going to work. So what next? So FAPI. So for those not aware, FAPI is the Financial API Working Group, part of the OpenID Foundation. I think they had a meeting just before this, actually, or during this, aiming to create a secure REST JSON-based API model protected by OAUTH. Obviously, a lot of commonality there, which is why the UK Open Banking Work Group is collaborating with FAPI formally and working together to build a open banking profile. FAPI does a few things, so it layers extra security onto OAuth and OIDC, enforces mutually assured TLS, disallows use of the implicit flow. We talked earlier about why you might want to do that, and also mandates token binding. So one of the big problems with OAuth is it's based on bearer tokens, which are effectively, once you get that token, anyone can use it. You know, it's like a $5 note. If I drop it in the street, anyone can use it. With token binding, you can bind that token cryptographically to the client-server TLS connection that it was intended to be used on. So you mitigate a lot of the potential attacks you might get, like man in the middle. There's a lot more to FAPI, and if you're interested, I fully recommend reading up on it. UMA. So again, we've got, I don't know if Kintara is still in the room, but it's used to manage access. So used managed access is a standard, again, built on top of OAuth, but it's designed to address complex use cases around consent and data sharing. So things like, in an open banking world, what if you want to share data with an individual, for example, or a family member? Or what if you want to define a trust and grant specific permissions to that financial trust to people, you know, directly, not via a third party, not via a bank? UMA is very good at those more complex consent use cases. And UMA is certainly something I think we're all looking at as kind of the way forward for open banking in the longer term. Okay, so again, I'll reiterate everything you've seen today, for the most part, has been open standards based, OAuth, OIDC, and FAPI, and the standards are there. All you need to get started is something to call REST APIs, and you need compliant vendor products. And you can look on the OpenID Connect certification site to determine what vendors, what products you might use. There's plenty out there. To do the payment initiation piece, you need to make sure they comply with Section 6. And that's it. Any questions?
Yeah, that was nice. Nope.
On your initial, on the first call that you made that had the request parameter in it, were you requesting any scopes other than OpenID?
Just OpenID.
Okay. And then, you know, after your redirect to the financial institution page, which listed, you know, do you consent to ABC?
Yep.
Did you have like a prompt equals consent as part of your request that you passed in, or what?
I had a different client set up. So I'm guessing most vendor products can do this, but the client I used for that last piece, I had turned on consent. So it's a client-based thing. It's not something in the request. Right. It's a configuration setting in the client you create. Okay. And normally you absolutely wouldn't have it off because you're very much kind of defeating the whole point of OAuth. But for understanding the flows, it's useful.
Okay, thank you.
So you mentioned something about scopes not being granular. So do you still see sticking to scopes for authorization, or having a different PDP that grows more granular depending upon your situation, and especially in the banking world?
Good question. So I think you've got banks out there like Starling and Monzo that are now using scopes, and you can achieve a level of granularity with them, absolutely. But where the challenge open banking had was the payment side of it. How do you actually initiate payments? And scopes aren't suitable for doing that. There's no easy way to do that with scopes. You wouldn't want to dynamically create scopes on the fly just for each payment. It doesn't make sense. It's not a good model. So we needed a better answer. So yeah, scopes still have a place, absolutely. But for this particular challenge of consenting to something dynamic that you don't know ahead of time what it is, the request parameter is perfect.
I might add something to that, actually. Wait, everyone here.
Only that if you tried to do it with scopes, you could literally create a scope that's, you know, even if you could do dynamic scopes, it would literally say Amazon, $50, blah, blah, blah. And now it's privacy violation, right? That's all in the...
It's not what the spec's about. It would be tearing it, well, certainly stretching it to its very limits. Yeah.
I'll go ahead and ask yours and I'll run this back to you.
Is that request parameter an either or? So for example, you know, I have a request parameter to dynamically request this particular payment transaction. and at the same time I want to, return first name, last name, or some other.
No,
silly scope.
you can do both. You're asking for specific claims. So in that scenario, you would just ask for a different set of claims, and you wouldn't obviously set, preset the value for name that you want, for example, because you don't know what it is.
Right.
So no, it's not either or.
Okay, thank you.
So in OpenID Connect, the use of a request parameter or the support of a request parameter is an optional feature.
Yes.
I guess it's an extension of FAPI to make the support for that feature mandatory by the OpenID Connect provider.
Yeah.
However, what I am missing in basic OpenID Connect is the option to make sure that a malicious user cannot just drop the request parameter and provide the claims parameter as an unsigned request.
Yep.
Is there an extension in FAPI that would say this client must use the signed request?
So there's a few questions there. The use of the signed request is being mandated by OpenBanking in the UK. So that's the chosen approach.
So it's just said a client must use the signed request, otherwise it's a non-valid.
If you want to be part of our ecosystem, the OpenBanking ecosystem, that's what you need to be able to support, yes. Ultimately, yeah, the plan is to align FAPI with that, I believe.
Okay, so that there would be a client property that a client could be registered with via dynamic registration that says, I only plan and I only intend to use a signed request, and if there is a request landing on the OP side without one, please throw an invalid request.
Yeah, that would be one way of doing it.
That's cool. Thanks.
But I don't know for sure that's the way it'll happen, but ultimately to be part of the OpenBanking ecosystem, the way that the UK is defining it anyway, you need the request parameter.
Thank you.
But now I want to go back and read it and see if it actually says that.
Yeah, I'm not sure.
Exactly that, yeah. Anyone else?
I wonder if you might speak to the liability concerns. I mean, today with online transactions using a credit card, I'm protected from the bad guys. I mean, if they abuse my card and purchase something, yeah, I'm protected. If somebody has direct access to my bank account and they wipe me out, who's at fault?
Well, so the hope is, well, the aim is to mitigate that with the entire scope and claims-based model, right? So, ultimately you consent to doing a very small number of things. You consent to this transaction for this amount of money, or you consent to reading your account data but not writing to it. There is definitely a liability question there, and I think from our point of view, we need to make sure the tools are in place. And again, this is why we look to things like OAUTH, UMA, and standards. And UMA consent receipts are probably relevant here if someone in the room could talk about UMA consent receipts. But there is liability concern, but so my role certainly has been, use sensible open standards, ensure that there's evidence, there's auditability, there's traceability, which you get with tokens. But you'd have to talk to a lawyer, I think, beyond that.
Anyone else? Okay. Thank you very much. Appreciate it, Wayne.